Good morning, students. So today we have to start with chemical equations. So let's start with this topic. So first of all, we should know what is a chemical equation. So a chemical equation is the symbolic representation. It is the symbolic representation of a chemical reaction in which the symbols and formula are used, where the reactants are kept on the left hand side and the products are kept on the right hand side. The first chemical equation was diagrammed by Jean Beguin in 1615. So let's see one example. That carbon, when it is burnt in air, it forms gaseous carbon dioxide. So here what you observe, it should be arrow acting. Okay, so carbon when reacts with oxygen, it forms carbon dioxide. So carbon and oxygen are the reactants and carbon dioxide is the product. Okay, where carbon is in the solid state. Okay, carbon is in the solid state and the oxygen is in the gaseous state. Okay, carbon is in the solid state and the oxygen is in the gaseous state, and the carbon dioxide formed is also in the gaseous state. So here you are also observing that during a chemical reaction there is the state change in the state of matter. So in this reaction the carbon is an element, so the symbol of this element is used. Here oxygen, molecular formula of the oxygen is used. So in the definition what you have seen, either we are using the symbols or formula. Okay, so symbols we are using, like carbon symbol is used and oxygen's molecular formula is used, and the product formed is the compound, so this compound's molecular formula is used. Okay, in between the reactants one plus sign is being used over here. So this plus sign is showing that this particular reactant is reacting with this reactant and it is forming this product. Okay, now we have to see what are the steps involved in writing a chemical equation. So the first step is the reactants taking part in the reaction are written in terms of their symbols or the molecular formula. Just now we have seen in the one example in which there is reactants are written on the left hand side of the equation and a plus sign is added between the formula or the symbols of the reactants, which is showing that those particular reactants are reacting together. And the products are written in terms of their again symbols or molecular formula on the right hand side of the equation. Then next step is a plus sign is again added between the formula of the products if more than one products are formed in a chemical equation, and in between the reactants and the products we use an arrow sign, and this arrow sign inserted to show which way the reaction is occurring, because we will see sometimes arrow in the forward direction, sometimes arrow in the backward direction, sometimes the arrow will be splitted half forward and half backward. So this splitted form of half forward and half backward is showing the reversible type of reaction, whereas the use of this symbol, this arrow, is the either forward reaction or the backward reaction. It means irreversible reaction. So use of this arrow sign is an example of irreversible chemical reaction, whereas the split arrow with half forward and half backward side will be the sign of the reversible reaction. So let's see one example. In this example, zinc oxide when combines with carbon and heated, it forms zinc and carbon monoxide. Okay, so the formula of zinc oxide is, molecular formula of zinc oxide is ZnO. Symbol of carbon is C. When it is heated, it forms zinc and carbon monoxide is formed. So carbon monoxide is again the molecular formula of carbon monoxide compound. Here we are observing on the left hand side we are having two reactants. So what are the reactants here? Zinc oxide and carbon. On the right hand side we are observing two products. So what are the products formed? That is zinc and carbon monoxide. Okay. We use the plus sign because more than one reactant is there. We use here the plus sign again because more than one product is there. Okay. And this equation is also balanced. So how it is balanced? On the reactant side, number of zinc atom is 1. Here on the product side also the number of zinc atom is 1. The number of oxygen atom on the reactant side is 1. Here also on the product side the number of oxygen atom is 1. The number of carbon atom on the reactant side is 1 and the number of carbon atom on the product side is also 1. So this is how the number of atoms of the respective element on the reactant side and on the product side is same. So that is why this particular reaction is the balanced chemical equation. This particular equation is the balanced chemical equation. And why we need to balance the chemical equation? Because we know the law of conservation of matter. And what is the law of conservation of matter? That matter can neither be created nor be destroyed. It only changes its form from one form to another. So here also the elements are neither created nor destroyed. Only the matter is neither created nor destroyed, only it is changing its form from one form to another. So that is why to obey the law of conservation of matter, we need to balance the chemical equation. So from the next class, we will see certain examples to balance the chemical equation. Here one thing is written, oxidation and reduction. In the standard 8, you will study about it, that oxidation is the addition of oxygen and reduction is the removal of oxygen. So in this reaction, from zinc oxide, oxygen is removed. So what has done over here? So the zinc oxide got reduced, whereas in carbon oxygen is added. So C2CO. Okay. So the carbon atom got oxidized and the zinc got reduced. So ZnO to zinc formation is the reduction reaction and carbon to CO formation is the oxidation reaction. So I hope till here it is clear to you all. Your homework is write down the definition of chemical equation, then write down one example to show the chemical equation, then write down all the steps involved in writing chemical equation and write down this reaction. This particular reaction is the word reaction and this is the chemical reaction.